Hello everyone, this is going to be a quick video on nuclear fusion.
What is nuclear fusion?
The reaction for nuclear fusion which would power a potential power station is the same reaction that the sun derives most of its energy from. This is the reaction of deuterium, which is an isotope of hydrogen, and tritium, which is another isotope of hydrogen.
So imagine two marshmallows colliding with enough force to make themselves one. That is a simple description of nuclear fusion, and it mostly happens in stars where they have enough heat and energy and light to function. Currently, on Earth, we have nuclear reactors that perform fission, for example, blowing atoms up. But what we really want is fusion, which is bringing the atoms together.
Fusion occurs in stars because the pressure of all the outer layers of the star gravitationally collapse the cloud of gas into a small enough region that the temperatures are hot enough that fusion occurs. Basically, for fusion to occur, you need high enough temperatures so that you can overcome the potential barrier between the nuclei. When you're pushing two nuclei together, there's a really strong repulsion between the two positively charged nuclei, which means that it's really, really hard to push them together. But once you push them together far enough, there's something called the strong nuclear force, which actually attracts the two nuclei. And that's what allows the nuclei like helium to actually be formed, that there's an attraction when the nuclei get close enough.
So the basic requirements for nuclear fusion to be a viable energy source are that it produces more energy than it takes to start a reaction and than it takes to power the reactor as the reaction is ongoing.
So when you are trying to get the molecules to come close enough to each other that they'll actually fuse in a fusion reactor, you need a huge amount of energy to overcome their natural repulsion. So the nuclei, the central bit of the atoms that we have, that really doesn't want to come close to another nuclei. They don't want to stick together. They want to fly as far away from each other as possible. So by getting to very high temperatures, you're putting in a huge amount of energy so that they will actually overcome that repulsion and stick together.
Stars have a seemingly infinite amount of fuel, so scientists at JET are looking to mimic stars by creating a fusion reactor.
When we run an experiment in the JET vessel, which is a big vacuum chamber, then we put the gas in, we heat it up to over 100 million degrees centigrade, and at that point there's enough energy there for the gas molecules to start colliding together and fusing. So most of the experiments that are done at JET at the moment are being done to allow us to understand better the science of fusions and the engineering concepts that we need to get right so that we can scale up fusion to a bigger scale for the ITER experiment that's currently being built in France, so that we can then work towards making fusion a reliable source of energy.
Wait, do it after she wishes hot.
With the idea of whole fusion is that palladium is a really amazing metal. It's absolutely fantastic at soaking up hydrogen.
Why should you never trust an atom?
Why?
Because they make up everything.
Yeah, I'm about to. Alright, could you get out my chair please?
Take like small bites.